Introductory Dimensional Analysis. We'll be learning to solve problems in this lesson by simply changing from one unit to another. Problem number 1 gives us information about 10 US gallons, and it would like for us to change this into liters. One equality is given in the problem that 1 quart is the equivalent to 0.946 liters. And we also have to have another equality that isn't given in the problem that could be looked up if not known, and that is that 1 gallon is the same as 4 quarts. When you have equalities, they can be written as a fraction with either part of the equality put on the top or the bottom to help you cancel units as needed. To begin a problem, I always like to identify the question. In this one, they're asking for us to calculate the number of liters. So notice I've placed a question mark there in the proper unit of liters. Now we're going to put right beside this a number that we're starting with. In this case, that is 10 US gallons. And what we're going to do now is go ahead and use our equalities in the form of a fraction to be able to change from gallons into liters. If you recall, we had the relationship that every gallon is the same as 4 quarts. So let's use that fraction. Notice when setting up this fraction, I placed the gallons on the bottom part of the fraction so that that unit would cancel out. And now if we were to do the math, we'd actually have an answer in quarts. Since we want to go on to liters, let's go ahead and use the other quality that is given in the problem, that 1 quart is equivalent to 0.946 liters. Using the second equality as a fraction, we're able to see that we can go ahead and change quarts into liters. And I'm going to be highlighting in blue the units that are actually going to cancel. So far we see that the gallons have canceled. We have 1 on the top and the bottom part of the fraction. The quarts are also going to cancel. Once again, 1 on the top and the bottom part of the fraction. The only unit that's left here is a unit of liters, which is what the question is actually asking for. So if we go ahead and do the math now, that is multiply the 10 times 4 divided by 1 times the 0.946 divided by 1, we'll get a numerical answer for this problem. We started out with 3 significant figures in the 10 gallons. Both of the zeros get to count here because they're at the end of a number with a decimal present. So what we're going to do is do the math and round our answer to 3 significant figures. So the final answer here will be 37.8 liters. Problem number 2. You have to pour 2 cubic yards of concrete for a patio. What is this volume in cubic meters? In this problem, I have given us a length equality to try and help us solve a volume problem. Anytime you have a length cubed, as we have in this problem, yards cubed or meters cubed, that is indicative of a volume unit. To be able to solve this problem, I'm going to take a length unit and change it into a volume equality. So we have that 1 meter is the equivalent of 1.094 yards, and notice that you can write that as a fraction with the meters on the top or the bottom. But what you're seeing right now is a length equality. If you recall, this is a volume problem. To actually change a length equality into a volume equality, all you have to do is cube both sides of the equality. When you cube this, you cube the number and the unit. Obviously 1 cubed here will stay just 1 on the meter side, but if you take 1.094 and cube it, then you'll come up with a new volume equality. So the 1.094 cubed actually is 1.309. So we changed a length equality to a volume equality by cubing both sides of the equality, both the unit and the number. So now we can solve our problem. Let's identify the question. We would like to know the volume here in cubic meters. So we have our question mark and the unit that is desired, the meter cubed. What we're starting with here is a value of 2 cubic yards, or 2 yards cubed. Now we're going to use our volume equality, not the length equality, but the volume equality to make this conversion. I'm going to make sure that I place a yards cubed on bottom so that that unit cancels. So using the equality provided, the one that we calculated, the volume equality, we can see how yards cubed will cancel. We have 1 unit on the top and 1 unit on the bottom, leaving us with the final unit of a meter cubed. This is the only conversion that is necessary, so now we need to do the math. 2 times 1 divided by the 1.309. For significant figures for this problem, the initial value of 2.0 only has 2 significant figures. So we're going to want to round our final answer here to 2 significant figures as well. So the final answer to this one is 1.5 meters cubed. If you used the length equality and not the volume equality, you would not end up with the correct answer of 1.5. The last problem we're going to do in this short video, problem number 3, is going to be changing a density unit of grams per centimeter cubed to the SI density unit of kilograms per meter cubed. So we're going to have to take care of the top and the bottom part of the fraction here. I have provided us with some equalities that you may be familiar with because these are simply basic unit equalities or prefix equalities. So we're going to take 100 centimeters and recognize that that's the same thing as a meter, and that 1,000 grams is the same thing as a kilogram. If you need to reference prefix definitions to help you set up these equalities, please do so. So to solve this problem, we're trying to identify the unit that is desired, in this case, that is the kilogram per meter cubed. We're starting off with a number, 13.6, that is in grams per centimeter cubed. We've got to take care of the top and the bottom part of the fraction. We're going to have to change the grams on top to kilograms, and we're going to have to change the centimeters cubed on bottom to meters cubed. And you got to be careful that you're keeping track of what unit's going to cancel on top and bottom. Let's take care of the top part of this fraction. Let's see if we can change grams to kilograms. You should recall that the equality was given that there is 1,000 grams in a kilogram. So using that equality, we'll be able to change grams into kilograms. Notice the gram unit will cancel because you have one on the top and the bottom part of the fraction. Now what we're going to do is see if we can get rid of the centimeter cubed on the bottom part of the 13.6. Now if you recall, a centimeter cubed is a volume unit. What was provided initially in this setup was a length equality, the fact that there are 100 centimeters in a meter. We need a volume equality, so we're going to have to take and cube both sides of the length equality. That is, 100 centimeters is equal to a meter. But if we cube both sides, you cube 100, then you're going to come up with 1,000,000. So if we use our volume equality, whenever we take 100 centimeters and we cube it, because that's the equivalent of 1 meter, then you have that there are 1,000,000, 100 cubed, centimeters cubed in 1 meter cubed. Once again, to change a length equality to a volume equality, you have to cube both sides. 100 cubed is 1,000,000, written in scientific notation here, 1 times 10 to the 6th. The 1 meter, when it was cubed, just stayed 1 numerical-wise. 1 cubed is 1, but it does have now the unit of meters cubed. So to reiterate one more time, to change a length equality to a volume equality, you must cube both sides of the equality, the unit and the number. You can visualize here, highlighted in blue, that the grams cancel, one on the top, one on the bottom. But the way we've set this up, you're going to see that the centimeters cubed cancels as well. Highlighted in blue, one on bottom and one on top. The only unit that is left now is the kilogram per meter cubed, which were the units that were desired. So now if you multiply everything out, the 13.6 times 1 divided by 1,000 times 1,000,000, that is the 1 times 10 to the 6th divided by 1, you'll get a final answer that needs to be rounded to 3 significant figures. 13.6 has 3 significant figs, so therefore our final answer should also have 3 significant figures. A couple of ways you could write this answer. The best way is in scientific notation, showing the magnitude of the number and the correct number of significant figures, and that is the first one shown, the 1.36 times 10 to the 4th, with the new units now of kilograms per meter cubed. 13,600 is the exact same answer, and as long as there's no decimal place at the end of 13,600, the zeros do not get to count, and that as well would be 3 significant figures. So both answers are correct. The second one is a little bit more ambiguous, and the first one would be the better answer. So this would be the final setup and the final answer in the correct units of the kilogram per meter cubed.